Chapter 11, Section 5, Volume of Prisms and Volume and Surface Area of Cylinders. So we covered polyhedrons last class. We did prisms, pyramids, and we're looking at cylinders. Now we're covering volume and surface area. So again, the formula sheet that was given to you on the quiz, it's also found on your Canvas page under SAT reference sheet. You guys will be getting that on your test. Volume, a couple things you need to know about volume for this. Volume equals, please be aware it's B times H, but B does not just mean your base. It's a capital B, which means the area of the base times your height. And you're going to see that capital B quite a few times on these slides, okay? Keep in mind the formula sheet does have volumes for certain shapes on there. So you guys don't necessarily have to remember all of them, but there are some that are not going to be given to you. Looking at this, it says the volume of a solid is the number of cubic units contained in the interior. So volume is the measure of what's inside. Volume is always measured in cubic units. So when you're writing your units, please make sure it has a 3, not a 2. Okay, it's cubed to the power of 3, not squared. Surface area is squared. Cavalieri's principle states that if two solids have the same height and the same cross-sectional area at every level, then they have the same volume. So if you're looking at this diagram, the height is the same. If the cross-sectional area is the same, then my volume is also going to be the same. All right, looking at this slide, it says volume of a prism. The volume of a prism is V equals B times H. Keep in mind that B stands for the area of the base. I know it's written down there, but I'm going to write it as well. Area of the base. Okay, that's my base area. So where B is, again, like I said, it's written here. The area of the base, and your H is your height. On your formula sheet, looking at a rectangular prism, volume is represented as length times width times height. Okay, so this is my length, this is my width, and they're giving you your height, so be aware where you can find all this information. I have my length, which is my orange line right here. I have my width, and then I have my height. All I'm doing is multiplying these for volume. Okay, length times width times height. Keep in mind for your height has to be that perpendicular line. So if they're giving you something that's slanted like this, a diagonal shape, it has to be the height at a 90-degree angle. It has to be a perpendicular height. You cannot just take the height of this slanted line. It has to be a 90-degree angle for your height. Do not forget that. Looking at my cylinder, like a prism with a circular base, a right cylinder, segment joining the center of the circular base is an altitude, aka your height of the cylinder. So if I'm looking for the height of my cylinder, my height of the cylinder is that perpendicular line in the middle. This could also be my height if they're giving me that measure, because it is a 90-degree angle to the ground. And then you have your radius. Okay, you're gonna need your radius because you have a circle. If I'm trying to find the area of my base, I need my radius. All right, cylinders, lateral area of a cylinder equals 2 pi r times your height. Keep in mind the r is your radius, h is your height, lateral area of your cylinder. Looking at my cylinder, what do I have? My cylinder is made up of two shapes, a rectangle and two circles. Okay, so that's what a cylinder is made up of. So lateral area, these are specifically talking about the area of my cylinder, not volume. So looking at lateral area, Think of it as unfold and side of cylinder is a rectangle. Okay, so you should know that the sides of your cylinder make a rectangle. Okay, total surface area of a cylinder is 2 pi r squared and 2 pi r times your height. So I'm taking that lateral area and 2 of my bases, your circles, pi r squared. What is pi r squared? Does anybody remember? What is pi r squared? Good. That's the area of a circle. How many circles do I have in a cylinder? 2. So I'm taking 2 of my base areas plus my lateral area. Okay, that's how I'm finding the total surface area. My surface area of my entire cylinder. So think of it as circumference times my height. Okay. So this is what it looks like as a, I guess, two-dimensional shape. If it was flat, everything was flat, this is what it looks like. And that's what I'm doing to find the total surface area. Okay. Now looking at my volume of my cylinder. The volume of a cylinder is your base area times your height. This is what you're going to see on your formula sheet. Pi r squared times your height. What do I need for that formula? I need the base of my area. I need my height, and then I'm going to need my radius to solve for pi r squared. So if I'm looking at this diagram, all I'm taking is pi r squared, which is my area of a circle, times my height. Okay, they're telling you what that b equals. And looking at it, b equals pi r squared, and then all you're doing is plugging in your height after that. Okay, keep in mind your height has to be that perpendicular height. So if they're giving you a shape that is a little slanted, it has to be the height at a 90-degree angle. Do not forget that, because sometimes that will throw some students off. Has to be your height at a 90-degree angle. All right, solving for these, it says use the diagram to find. They want me to find 4 different things. However, within those 4 different things, I'm going to find 3 answers. I want you guys to be able to understand these. We kind of covered this in the last few lessons. I'm going to find it 3 different ways. In terms of pi, I'm also going to find it using 3.14 for pi. And then my last one's going to be using the pi button. Okay, so using the pi button. So I'm going to go ahead and find all 4 of these in all 3 ways. So looking at the first one, they want me to find the area of my base. I'm dealing with a circle, so how do I find area of a circle? What's the formula for that? Good, it's going to be pi r squared. So pi r squared, looking at my diagram, my radius is 5. Plugging it in, I'm going to have pi times 5 squared, leaving it in terms of pi. 5 squared is going to be 25 pi centimeters squared is my answer for this one. Now they want me to use 3.14 for pi. So still using the same formula, pi r squared, I'm going to have 3.14 times 5 squared. Plugging that into your calculator, I'm going to get 78.5 centimeters squared. And then looking at the last one, using my pi button, I'm going to round to the nearest 100th degree, or 100th decimal. So same thing, pi r squared. I'm going to have pi times 5 squared using my pi button. If I rounded correctly, I'm going to get 78. 0.54 centimeters squared. Looking at all my answers, they are different in their own ways, and yes, you have to know how to write all of them accurately. So if you're rounding incorrectly, or you're not putting a decimal, or you're leaving it in terms of pi when it asks you for something else, it will be incorrect. So please make sure you're aware of the directions. Looking at the next one, it's asking me for my lateral area. So for this formula, it's 2 pi r times my height. I'm going to have 2 pi times my radius, which we found was 5. My height is 7, looking back at the diagram. And then leaving this one in terms of pi, I have to leave pi last. So plugging into my calculator, 2 times 5 times 7, I'm going to get 10 times 7, which is going to give me 70 pi centimeters squared. That's in terms of pi. Now using 3.14, I'm still using the formula. 2 pi r times my height, 2 times 3.14 times my radius, which is 5, times my height, which is 7. That one's a pretty easy one just to plug in. Plugging it into my calculator, rounding to the nearest hundredth if it can, but this is going to give me 219.8 centimeters squared. And then my last one is using my pi button. So using my pi button, looking at this one, I'm going to have still 2 pi r times my height, 2 times pi times 5 times 7, using the pi button on my calculator, rounding to the nearest hundredth degree. I'm still going to get 219, but it's going to be 0.91 centimeters squared. And again, that's a little bit different than 3.14, using 3.14 in terms of pi. So make sure you're paying attention to that and using the pi button. All right, looking at the next one, I need total area, which just means the surface area, the total surface area of this shape, of this cylinder. So formula for this is 2 pi r squared plus 2 pi r times my height. Plugging in what I have. 2 times pi times my radius squared plus 2 times pi times my radius, which is 5, times my height. We solved this one already. We ended up with 70 pi. Keep in mind I'm leaving it in terms of pi. And then 5 squared was 25 times 2 gives me 50 pi. All I'm doing is adding these two together. If I added correctly, I'm going to get 120 pi centimeters squared. That's for my total surface area. That's in terms of pi. Now the next one was asking me 3.14 for pi. Solving this one, I'm going to go ahead and look at it. Because this is what I had for in terms of pi, I'm just going to use the same thing and change my pi to 3.14 just to save me some time. 120 times 3.14. Plugging that into my calculator, 120 times 3.14. I'm going to end up with 376.8 centimeters squared. I'm still dealing with area. And then the last one asks using the pi button. So I'm again going to take that 120 pi, just plugging that into my calculator, 120 pi, and that's going to round to 376.99 centimeters squared. So a little bit off than 3.14. Okay, so please understand how you're finding these. Going ahead and doing the last one. The last one's asking for volume. Formula for volume is capital B times H. So it's my base area times my height. Could also be represented as pi r squared times height. Plugging in, I have in terms of pi, my radius is 5 squared times my height, which is 7. 5 squared gives me 25 times 7 is 175 pi centimeters cubed, because volume is cubed. Looking at it as 3.14, all I'm doing is substituting my pi for 3.14. 175 times 3.14. That's going to give me 549.5 centimeters cubed. Here's my 1. And then the last one, using the actual pi button, 175 pi, plugging that into my calculator, I'm going to get 549.78 centimeters cubed. So those decimals are quite different for that one. All right, looking at this example, it says, find the volume of a square prism that has base edge length of 5 feet and a height of 12. So as best as you can, go ahead and draw a square prism. So here's my square prism. Again, not the best, but this is what it should look like, something like this. It says my base edge length of 5 feet. So this is my base edge length. This is my 5 feet right here. Okay, keep in mind it's a square. So all of these sides are going to be 5 feet. And then it told me a height of 12 feet. They want me to find the volume. I know formula, volume of a rectangular prism or a square prism is my base area times my height. And my base area, to find the area of a base for a square or a rectangle, is length times width, and then I have my height left over. So looking at this, solving, I'm going to have volume equals length and width are the same. You could put 5 squared, or you could put 5 times 5 times your height, which is 12. You're going to get 25 times 12, which is going to end up with 300 feet cubed. Okay, again, you will be given that formula on the formula sheet. All right, looking at this, it says find the volume of the puzzle piece shown in cubic inches. If you're looking at this diagram, how can I find this? This is a composite figure. Composite figure is made up of one or more shapes. So looking at this shape, if I were to split it right here, I have a rectangle and a square. I know I could find the volume of that square. All I have to do is add both of these volumes to give me the total. So volume for a square or a prism, volume's going to equal length times width times height. What's the length and the width and the height of this cube? 1. So my volume for this is going to equal 1 units cubed. And looking at this diagram, my volume equals length times width times height. What's the length, what's the width, and what's the height? Good. 3 times 1 times 2. What's 3 times 1 times 2? My volume's going to equal 6 units cubed. And then they want the total. All I'm going to do is add them. Volume equals 1 plus 6. I'm adding my 1 volume and my 6 volume, so my volume's going to equal 7 units cubed. And that's it. Looking at number 4, it says the volume of a right cylinder is 684 pi cube. It's inches, and the height is 18 inches. Find the radius. So just giving you a quick rough sketch. Here's my cylinder. it's saying that my height is 18 and it gave me my entire volume. So I have to know how to find volume of a cylinder. So let's see, are they giving me volume of a cylinder? All right, formula sheet. Are they giving me that one? Yes, they are. Okay, so that one is used right here. So volume of a cylinder is pi r squared times my height. So they're giving me the volume. So how am I setting this one up? Just writing out my formula. Volume equals pi r squared times my height. They gave me my total volume, which is right here. So setting it up that way, I'm going to have 684 pi equals pi times my radius, which I'm trying to solve for, times my height equals 18. So plugging that in, solving for radius, go ahead and solve it. All right, solving for radius, there are multiple ways to solve this. However, this is how I'm going to solve it. Solving for my radius, I'm going to divide both sides by pi. My pi's are going to cancel out. I'm going to end up with 684 equals my radius squared times 18. Divide both sides by 18. If you divide it correctly, you're going to get 38 equals your radius squared. Getting rid of my squared by square rooting. And your radius is going to equal, rounding to the nearest, we'll do tenths, 6.2 inches. That's my radius. So you guys have to be able to know how to work to find something else. Find the volume of the oblique prism. So finding this is a, if you want to call it a triangular prism that is not given to you on the formula sheet. So you have to know how to work with this one. So looking at it, volume is, we know volume equals the base area times the height. What's the base of this shape? You could tell me, what is the base of this shape? A what? What's the base of this shape? You have to know how to find our base, yeah?
8.
No, my base is not 8. What shape is the base? I'm just asking for the shape. Yes. It's a triangle. How do I find the area of a triangle? Good. So if I'm looking at it, this is my base right here. It's a triangle. So base equals base times height divided by 2. Keep in mind it's a lowercase b. So I know those measurements. Keep in mind it's the base of the triangle at a 90-degree angle, which they are giving me. So plugging in what I have, I'm going to have my base times my height of my little triangle divided by 2. Remember, formula for volume is the area of the base times your height. This is the area of my base. I'm going to end up getting 45, or not 45, 45 over 2. And I'll change it to a decimal, 22.5. I don't necessarily have to, but it's up to you if you want to. Now I'm going to take that measurement and multiply it by the height at a 90-degree angle. So if I'm looking at it, this is my height at a 90-degree angle, which is now 8. So all I'm going to do is plug it in. Volume equals my 22.5 times my height, which is 8. If you multiplied correctly, your volume is going to equal 180 meters cubed, because that's what I'm solving for my volume. So this is my volume of this shape. All right, similar solids. So similar shapes, two solids of the same type with equal ratios of corresponding linear measures such as a height or radii. So most important thing is the ratio of the corresponding linear measures of two similar solids is called a scale factor, which we have dealt with. So we're dealing with scale factor again. If two similar solids have a scale factor of k, scale factor is represented as k, then the ratio of their volumes is equal to your scale factor cubed. So pay attention to that. The ratio of their volumes, so I need to set their volumes up as a ratio and set it equal to the scale factor that is cubed. All right, looking at this example, it says prism C and prism D are similar. Find the volume of prism D. So they're giving me one, but they're not giving me the other, and I have to find the volume. Most important thing that I highlighted in the last slide. The ratio of the volume is equal to the scale factor cubed. So I have to first find the scale factor. Scale factor is equal to k, and my scale factor, I'm going to use the sides. I have 12 and 3. My scale factor is going to be 12 over 3, which is going to give me 4. My scale factor is 4. Again, my ratio of my scale factor is equal to it cubed. My scale factor cubed. So 4 cubed, plugging it into your calculator, is going to give me 64. So I have to go ahead and set up a ratio. Setting up my ratio, I have the volumes, 1536, over, I don't know my volume of D, is equal to 64. Now I have to solve for my volume D. So what am I going to do? I'm going to go ahead and multiply both sides by volume D. And then I'm going to go ahead and set it up. It should be 1536 over 64. And that's going to give me my answer for volume D. So plugging that into my calculator, if we solved it correctly, volume D is going to equal 24 meters cubed.